If you want to keep building up the number towers, then you need a way of representing negative numbers. One way to do that is to represent all numbers using a pair with a natural number, a non-negative integer, as the first part of the pair, and then a Boolean for a sign. Right? And then you have to implement add and subtract and all these operations that work on this new encoding. They can use the ones that work on natural numbers as a helper function, and so on. And once you have positive and negative integers, you can make rational numbers in general out of that. It's just a lot more functions, and you can build complex numbers on that, and so on. So it's the same thing that you do if you're building up these kinds of fancy numbers in other languages, where you start with bits. We're just starting with functions in the lambda calculus instead. What we would get out of this exercise is an implementation of numbers that's not very efficient at all compared to the representation that works in terms of bits. That's partly because our hardware knows about bits, and partly because bits have different properties than these functions. But all of those numbers encodings are at least possible. So what I hope you see from this exploration of encodings is by starting with a very small language, as small as it can be, the lambda calculus, we get functions and local binding because we can encode let using function, and we know how to encode booleans, and we know how to encode numbers, and so on. In fact, using the lambda calculus, you can write any computation that you can write in a general purpose language. It is Turing complete. And that may be a little surprising until you've seen these kinds of encoding strategies that we've seen today. Again, we are mostly not going to change Mo to use these encodings because they're very inefficient. And so it's a trade-off between building something into the language to represent it and implement it more directly versus encoding it. But it's important to understand that we do have this option, that we can add to the language with syntactic sugar and not necessarily have to change the rest of the interpreter. And it's not just about Mo, because possibilities and strategies for encodings can be used in any language, where you can write new libraries to build up new things using these kinds of encodings.